Hi, welcome back to video 2 of the Sapphire series of videos. And now we're going to kind of take a step back and we're going to walk through the other configuration and management menus enabled on the Sapphire and how you would achieve and basically get to those settings. So I don't think we did any of this in the previous video. So to start with, in the configuration menu, you have a network, your date and time, IP control settings for the executive, logging, your high availability if you do VRRP or load balancing, services, system, and a few other licenses here. So to begin with, in the network configuration, you'll have your FQDN of the device. This is what we set in the startup menu. Your DNS servers were set there. If I need to add another, I could edit this system, do a comma, a second IP. If I want to enable IPv6 networking, I could do this now. And then you have your default gateway. Now, we do provide also denial of services as part of a built-in license feature. So it's not anything that you have to license this separately. And it uses adaptive rate limiting that you can enable or disable. We can go in and set up the threshold settings. So you have DHCP, you have DNS. These are just the defaults, and then you would modify those accordingly. Now, what these are measuring effectively is in the adaptive rate limiting is the source IP being the client or the source IP of a client, and that is receiving X number of packets per minute per client. So from a DHCP perspective, 125 from any particular source IP other than a router would be effectively something like that. So we might need to increase this, and we might need to say even that with the DHCP, we might have more than, we might say this is 1,000 packets. Anything over that, now this might be like your IP relay, because again, it's going to catch all the IPs. So something like this you can set. Now we might also want to say that, 150 per second is going to be the threshold, and that would be more realistic there. So we'll do that. And DNS will do the same. I'm going to do 10,000 per second, because I don't think even in most environments, in a load balance environment, that you're going to get that much traffic. So we don't really want it to overwhelm our server. And if we are, it'll start adaptively scaling back that information. Now, while we're here, let me go ahead and apply this first. You then have exceptions. So you can now set up your exceptions from that rate limiting, and now you can set up the rate limit for the routers. You can do the load balancers, the IP helpers, and things that you can now accept from that list. And then you can see the live status. So if anybody's being blocked, and if you're troubleshooting, this is where you would go in and see that. So that's your network. In that network configuration, you're going to have that particular setting here for denial of services. Now, the interfaces is where we'll get into the 4 interfaces. And what I want to show first with your virtual systems is it shows you that GLAN 1 is mapped to network adapter 4. And you'll see that these don't cover any particular order here. So 4 is basically the adapter that we're going to start on. So that's when you're looking at your ESX server and it shows you virtual network interface 1, 2, 3, 4. This is the 4th one, and that's GLAN 1. So if you're enabling, disabling anything, anywhere, you want to make sure you do it accordingly to this mapping. And this is available in all systems. And it's effectively the same, I think, in all systems as well. Now, one thing you may want to do in the first is we put this private IP address in there. And I guess in terms of access, since you don't have anything physically to plug a port in, it doesn't make sense to even have this enabled, since we don't also support, let me go ahead and disable this. It's going to ask us to reboot, and I'm going to tell it to do no right now, but you may want to do that. And I'm just going to skip it because we may come back to another setting here at one point. Okay. Now, once I've disabled that, you'll see here your GLAN 1, 2, 3, 4. You can set up any one of these IPs. You can route them any way you want to virtually. And then the management interface is bound to GLAN 1. And that's really all you're going to get here in effect. But when I go into my GLAN, I then have my IP addresses, mask, any MTUs, And then I can set up any number of additional IPs if I want to do secondary addresses. So 10 addresses basically total for the interface. So this is one way that we've used or used this ability to take over servers when we migrate away from one vendor or product to another. We can consume their IP, take over the zones, take over the scopes, and just put it into the secondary there. Now, one word of caution of that is when you're dealing with DHCP, typically when you send an IP relay to one IP, it expects that source IP to be the returning IP of that DHCP server, or it might get caught up in spoofing. So if you're dealing with multiple IP addresses, you may have to make some rules or exceptions there when doing that with DHCP specifically in that case there. All right, so you can do this, add, take away your interfaces as needed. The next setting here is any kind of static routes. And from a static route perspective, if you're only using one interface, there's no reason to do this. If you are using a management interface and then a service interface, and the service interface were not on the primary GLAN 1, then you might want to set up routing to ensure that you go out a different default gateway and then set up firewall rules on all of the traffic coming into it to control who and what services can access. That's extreme in locking it down, but for protection, that's the best way to do that. And so we do enable and support static routing. And even if you don't do that, you may have to set up static routes for certain networks to get through different networks and firewalls and routers and such. So that's your setting there for static routes. Now you also have Anycast addressing. So if we were going out and enabling OSPF or OSPF v3, BGP, Anycast, we could set up that we're going to enable that and then go through the various settings for the OSPF. And this is then used using a Zebra daemon behind the scenes in the operating system to monitor DNS. And if it goes down, even the DNS or the service, that it injects or removes the route and injects a new route. So all of these servers participating in Anycast with a particular IP will inject their route based on availability. So it makes that determination on the systems. So I don't have anything here in a router sense to do this, but you can do that if you have. The IP address labeling here, you can set up policies that you define your labels that can give it like network labels. This then shows you all of the different networks, private, V4, V6, and set up policies around these around access. So I don't use these very often, but some customers may. So now going back to our date and time, we then have your configuration of where you're going to use either Crony, NTPD, or you're going to use manual settings. So number one, and we set it up to use Crony, which is a new version. I recommend Crony. It's actually very quick, or NTPD. The hypervisor, you do need to make sure all of that's working properly because I've seen it unsync sometimes. So I prefer not to use hypervisor, just as a no. And then underneath that configuration, then you can set up your time zones. Now I set mine up locally, but you can go in and change this to be UTC if you want to do everything in a common format, globally. You can do all in UTC format. Probably recommended you do that, but all up to your environment. And then if you're doing configuring the NTP, you then have your servers, peers at ACLs, and you have authentication if you want to use keys. So we here then would set up the server, and I only had the one when we defaulted to the screen, but I may have others here that would be defined, and you would typically have more than one or two, in that configuration. Okay, and so that's under the configuration for time, and then we'll go back to our next setting, which is IP control, and this is where we're going to define, here is your IP control executive. This is the manager that we're going to go and connect to when we need new files or we're told a configuration is ready. We're also going to tell it what services to start on boot. This is my DNS. I haven't told it to start DHCP here yet. And then you can also tell it how many CPUs are dedicated to this DNS process. And so we recommend 8, which if it's dedicated DNS, you can, but you can also mitigate that and maybe do 4 if it's on maybe a really busy server or a less busy server and you want to use it for something else or other process. Now you also have a hot standby, which is the DR executive. So All of these appliances can be configured with a primary and a backup executive. When we go through an executive, if it were to fail over in DR to the DR backup, and it starts up in the active MQ, which is a messaging service, begins. These systems would note that the primary is down and they would automatically reconnect to the backup. And they can then start taking instruction for new configurations or updating files and so forth. So it's just one of the automated procedures, and then if you fail back, it'll automatically fail back. So it's to ensure that all these devices automatically connect, and you never really even may know about it. So you might want to put some monitors on it there. And the DNS tunnel detection. Yep, sorry, hit the wrong one here. I'll come back to that. DNS tunnel detection is also a licensed feature of our Sapphire. So it's not something you have to license outside. It's built in. And here you'll then establish basically enabling it, setting up the time and the tunnels. And if I can get to that menu here one more time, you can then tell it the monitoring of seconds. So what constitutes a tunnel in terms of seconds and in terms of sessions. 10 seconds seems to be sufficient, and you can use the defaults. Now, we do also offer a auto shutdown feature. So once you've worked through all of the different tunnel detection, you determine what's real, what's not real, got rid of all the false positives. You kind of need to understand these. You can then go in and set up an automatic shutdown, which uses response policy zones. And those response policy zones will be instructed to shut down that client IP. So dynamically, it would put the client IP into the zone, which would replicate to all of the resolvers dynamically, and then it would shut down that client. So everything that came in from DNS would then drop, and not even in domain, it would just drop it. So it's an automatic tunnel. It then allows you to do this in real time, and then you can go in and manage that tunnel. Also setting up alerts that, hey, we've got something out here that's tunneling and exfiltrating data from our network. I'm going to keep this thing alive there. So that's a DNS tunnel, and that's another feature available to all of our Sapphire users, built in. There's nothing else you need to acquire. Now, the other I had hit inadvertently is the V4 V6 pool alerting. So we do have this process to go out and run every 5 minutes. A DHCP pool alert scans through all of the scopes, all of the leases, and then based on these warning critical, it sets up either some type of alert, an SNMP or an alert event that can be picked up through the callout manager. So there's a number of different capabilities for alerting in real time, which would then give you the ability to be proactive or more proactive in the scope and the management of it. So if this were set at maybe like 95%, you might need to go back in and start pruning leases, doing something like that, which we also have the ability to set up that auto pruning to set up and clean up the pruned addresses, abandoned address, try them again. And so that's a nice feature there. Now, when we get into Active Directory, we have a feature of signing using GSS-TSIG. The normal way that ISC DHCP works is it uses TSIG. And with our bind and named, that works fine. When we get into environments where we use a Sapphire, we can come in, we can replace a Microsoft DHCP server entirely, import all of its scopes and leases and reservations, deploy them onto a Sapphire, and then set it up that we will sign these records just like Microsoft would on behalf of the client and update their record dynamically, giving us the ability to control that versus allowing the client being more secure. So it's the same method. You then set up a DNS type admin that has that ability to read, write, delete records. And then you would set up the principal user and password. And we'll sign those in GSS-TSIG and capture it and handle those dynamic updates. So that appliance then can be either ISC or it can be Windows DNS. So you can pick and choose, which is a great option there. And then that's where we'll have the DNS Update Manager, which will come into play. So that's IPControl. Those are just the basic services. You then have logging. So we use our syslog. You have the ability to manage what level of log detail, standard here. You then have, we'll go through different remote logging, and you have basically securing those logs. So you can secure the remove old logs, which will basically purge those. You can also set up remote logging hosts where we can forward this off to a remote logger. And then you can set up the different alerting types, criticality, and the channels. So if I want to do like informational, local 6, something like that, I can forward that detail explicitly, pick it out of the different channels. And then you also have the option, like we do with NTP and some other places in the tool, to do expert mode. So if you have your own syslog configured, NAR syslog, and you want to do anything you want, you have direct access to rewrite and do anything you want from a syntactical capability. Which gets us into high availability and a little bigger discussion, but I'll touch on it briefly. We support VRRP, so the Virtual Routing and Redundancy Protocol, and it's used for devices that basically are on the same subnet when you use them in a VRRP peer, or we allow you to use VRRP as a way of doing load balancing and using real clustered IP addresses for DNS servers behind it. So effectively, you pick and choose which GLAN we're going to listen on, what the VRP ID is, the virtual IP address that you would have your clients point to, and then the network mask length that we're going to handle. So what we would then do is whenever we set this up, and let's see if we'll go ahead and do this here. Let's do 10.10.0.22. All right, and that will then open up our cluster server. So I now have a virtual IP and it created a VRP interface. And that VRP interface is VRRP.42. If I were to look at it, and I think I can here actually. Let's take a look. Yep, there it is. So here's my VRP, and that's my virtual IP address. Now, on the same system, such as my second system, and I'll probably go over and do this, I can enable VRRP and have the two share that virtual IP address. They would then load balance between them, and whichever system were available would be the active, the other would be standby, and you'll see it down here in this list. And you can have multiple peers, any number of them, and say 4 or 5 on a whole system. That would then be the back end to a load balancer, perhaps, and the load balancer points to a virtual IP that points to multiple others. So you can do multiple layers of this. And then you can enable those real cluster IPs and do either round robin or weighted round robin when we think of the scheduling. So here it's a weighted round robin. You tell it what percent of traffic to send to each of the different services. You then set up your real servers. So if I had one here, I might have, this is a VM1, the real IP, and this is my real server. And then I have my port in the real server weight. So we'll go ahead and apply that. Okay, and that's one. So I can have up to 8 different real servers. And then the idea with this is if you want to go in and you want to set up something, you can, hand it, have multiple servers in a pool, and then you can take them out of that virtual pool as you need to do maintenance and management and let it pick up all of the other routing and round robining between the other servers. So it's I'm going to say it's a basic load balancer, but it uses the weighted round robin. It doesn't do any kind of status or question to the actual server. It just does it based on traffic inbound. So that is VRRP. I'm just going to turn it off just for the case of going through this right now. Okay, and that'll change it as well when it re-enables that there. And then we get back into the services again, and this is where we're going to get into things like SNMP. So this device can be both, you can enable SNMP so we can query it. So I can turn it on and enable it. And I have about 12 minutes left of this video, and I'm going to have to maybe start a second one here, but I think I'll try to get through this. Yeah, so there's your, then you have a MIB state, and now the MIB state allows us to set up location, contact name. These are your sys description details. And then we're going to have the protocol, whether you want to enable or disable. So we would probably disable 1. We might enable 2. You might enable 3. Set your community string, and then set your active MIBs. So if this were DNS only, there's no reason to enable DHCP, V4, V6. But if you're doing DNSSEC, DNS, you can enable those counters. So we would do 1, enable it. And it's going to do this each time. It'll stop, start, re-enable it. Okay, and I want to just do 2, and it's going to have to do this again. And I think I will do 4 next because we are going to do DHCP on this eventually. So I do want to show that because we do have some very nice S&P MIB tables for the DHCP that shows all the pools, utilization, reservations, and a nice counter for polling, for monitoring in stations that are capable of that. All right, so let me do that one last time, and then let's go ahead and move on from there. And then we'll come back in another video, and I'll show you some of this using a tool that does S&P polling, and we'll see what that looks like. Sorry, my virtual systems are a little burdened this morning. Let's go here. And now that's our active in MIBs. I'm not going to enable V3 right now. If we need to, we'll come back to that. We'll do it one more time for S&P. All right. Now, and then you can have traps. Now, traps on this system, it was whenever it observes one of these events or triggers on the services go down, etc., you can set your syslog trap server. And we'll come back and do that as well when I get to that point. So that's S&P. Then you have SSHD. Now, here, one thing I recommend is that you change this idle minute. And I would probably do 180 minutes if you were looking to do something like a OS upgrade, something like that, and that'll give you 3 hours. Otherwise, you might get shut out there. And then you have file transfer services. So if we wanted to enable any of these types of protocols, HTTPS, FTP, TFTP, we can enable this device to accept it as file transfers. And you might want to use that for, with DHCP, your images, if you're using anything for DOCSIS images or other types of boot files, things like that. And we have the REST API services we went through before, and I haven't gotten to AI-driven alerting yet, but maybe we'll come back to some security things later on. And then system, I think we have a few devices here, so you can do the login message, so you can set up your custom shell message when you log in and your disclaimers. You do have, in the terms of the devices, you have storage, and we have an LVM that allows you to extend and monitor and do things with your logical volumes. So if I take a look at my extend logical volume, I'll see here my size currently where it's at, and like the diagnostics, I might need to go in when I do an upgrade and extend my diagnostics to something like 30 gigs. So let's go and extend this 30G. Now it needs to be at least larger than your database size. So if you were to do an upgrade, it exports it, you would need to make sure that you have enough space there. Now you'll see that I added on another 30 on top of 50. Now I have 80. That should be enough for most large databases. Now you may want to come back and change that at some point and go from there. The messages you'll see, it'll tell you successfully did this, so you'll see there, and you'll want to clear that at some point. And then, of course, when we come back with this, when we're done, we want to reduce it, change it back so that you can use it for something else. And then we would reduce this by 38 gig. I'm just going to cut it in half like it's suggested there and go back to that number. All right. And that does it logically. So it'll just handle all of that for us. And then the mount and FS share, you can remotely mount a share and have it mounted locally, and it'll handle that for you. Okay. So that's the devices, and that's the storage. You want to keep that in mind, especially on the executive. We don't typically see that on the DNS. You need to do this, but the executive, you will. Now, the others that we'll have here, you have the password policy for this, and I think here, your minimum length and time. And we do support external authentication, which we'll come back to for AD and some others in another video. And I'm getting down to the end of this. So IPAM auditor feeds, this is what enables and tells our system to send the data to the IPAM auditor. We haven't covered that yet, so I'll come back to this. But this is also where we'll enable DHCP fingerprinting and other things. And we have some other capabilities here. So you can see the alerting, the email, and other, even down to the kernel parameters if we need to tune it to that level. And that's the configuration screen. Now, the rest of this, you have management and you have diagnostics. So in the last couple of minutes, I'm going to cover diagnostics. In real time, you have real-time capabilities that give you things like top bash top, H top, NTP stats, and you can see the list. Some of these here, if you're looking for like adaptive rate limiting, current block sources, you can look at the DNS buffers, or if you're dropping anything, or if you think you're dropping things in the package, you can look at that here. So there's quite a bit here that's really very nice. NTP stats are good, gives you a nice stat, tells you what's happening, and so on. So I find these helpful there. Then you have some others here that when we go to like system information, where you can get your overall, your license key, your menu, the install services, other details. We'll probably ask for this if you ever ask for support, on anything here. And then you have your network reachability. So here on the network reachability, we have things like doing a routing table, pinging, and doing some other checks to make sure that you can get out from this device and service here. So just some network reachability. And then you have a collection of diagnostics. So if you ever call into the TAC, they're going to give you some other details here. And this is also where you can go out and watch the daemon log, which is where all of the DHCP and DNS and other packets come in. So if you don't want to go into the shell, you can do it through here, through app admin. Press enter again to stop it, and head back. And then you can copy all the system logs after for collection. And this will copy it to the diagnostics partition. And I think in terms of this, let's do system hardware, give you a show, kind of what it thinks it is, just kind of real quick. CPUs and other things. All right. And then I'm gonna have to come back over here on some of these utilities, but we have a couple here, one of which we call DNS top, and I'll just kind of show you this. And as we get into some of the command lines, then I'll go over some troubleshooting tools like TCP dump, DNS top, DHCPD pools to see real-time stats and then output it to JSON or see the MAC addresses and others. And then we have some other, like TMUX, we have capabilities and some other things here that help our system managers and clients and administrators who do need to get into the systems and maintain them to do that. So that's a long video, apologize, but it does give you kind of a high-level walkthrough of the configuration screens and some of the diagnostic and management. And then just, so we can see that system notification, you can delete these or export them. And I'll just save that off. And that will conclude our video. And we'll see you in the next video. We'll come back and talk about some of the management and then some of the utilities for troubleshooting and other capabilities. Thanks again. Take care, and I'll see you in the next video.